A student has sent an email asking about this question. How do we get the answer? Consider a monopolist facing a demand curve given by Q equals 30 minus half P, where P is the market price and Q is the quantity sold. The monopolist's marginal costs are MC equals 2Q. There are no other costs. What is the monopolist's deadweight loss? And here you have to calculate the size of the deadweight loss. Okay, so this question is a little bit long and involved. The first thing I want to do before I do anything else is to rearrange this equation here a bit. Because as you can see, when we normally draw, say for example, we represent these things on a graph, we're going to put quantity on the horizontal and we would put normally monetary values on the vertical, such as price, marginal revenue, marginal cost, and so on. Okay, so that's what we want to do here. We've got this expressed with on the left hand side, the marginal cost, but here we've got the quantity expressed on the left hand side when really we want it as a price. So before we do anything else, before we even start answering the question, we want to rearrange this equation. So let's do that before we do anything else. So we want to put P on the left hand side, Q on the right hand side. That is the form in which we want our demand curve to be expressed. Now we can start to answer the question. Okay, so remembering what our equation was, and our other one was the marginal cost equation, which I'm going to represent by C prime. So let's see, what are we going to do first? Let's do it in terms of a graph first, see how far we can get. Now we're going to start out, let's start with the demand curve. That's this one here. So we know this has the form of a linear equation. So vertical axis variable, horizontal axis variable, A is the vertical intercept, B is the slope. So the vertical axis intercept is 60. The slope is 2, or 2 over 1. It's negative 2, it's downward sloping, multiplied by Q. So when we've got a slope, that is the rise over the run, and we know the rise, we could express it as this, that's the rise, 60, over what must the run be in order for this to be equal to 2 over 1? Well, the run has to be half that, so it's got to be 30. Then we just join the dots, roughly, and there's our demand curve. So far so good, and we also want the marginal cost curve. So for the marginal cost curve, this is also a linear equation, but it might not look like it because it's missing a vertical intercept, but that just means the vertical intercept is 0. Vertical intercept of 0 plus slope of 2 times quantity. So we're going to have a starting point here, and it's going to go up with a slope of 2. Okay. For every 2 on the vertical intercept, it's going to go up by 1 on the horizontal intercept. So if it went up by 60 on the vertical intercept, it's going to go up by 30 on the horizontal intercept. So that means this is another point on this linear marginal cost curve. There you go. So we've got a demand curve and we've got a marginal cost curve. So far, so good. Now, this is a monopolist, so it's going to choose an output level where marginal revenue equals marginal cost, assuming it's a profit maximizing monopolist, which means we need a marginal revenue curve. What do we know about the marginal revenue curve? Marginal revenue curve has same vertical intercept as demand curve, but double the slope in absolute terms. So double the slope would be, chose halfway here. There you go. Double the slope. Bang. Bloody beautiful. Okay, there's your marginal revenue curve. So our firm is going to choose an output level where marginal revenue equals marginal cost. All right, so because what we're looking for is what? Our deadweight loss. Right? The firm's going to charge this price. So the price is going to be here. The firm's marginal cost is going to be here. And this area here will be the deadweight loss. So we've got to figure out how to get to that, which means we need to know first, what's this profit maximizing quantity? Q pi. And from that, we can get the cost, marginal cost, and the price. So how are we going to figure that out? Well, we have information we can use. We can say, well, what is the quantity at the point at which the marginal revenue curve and the marginal cost curve intersect? We need an equation for our marginal revenue curve. Well, that's not too hard to figure out. It's a linear equation, so it's going to have the vertical intercept that starts at 60, and it's downward sloping, so it's a negative slope. And what is that slope? It's double the slope of the average revenue curve. What was the slope of the average revenue curve? 2. So it's going to have double that slope, 4. There we go. There's our equation for the marginal revenue curve. Now, what we want to find is what is the quantity when marginal revenue equals marginal cost. All right, so let's see if we can figure that one out. So what we'll do is take this equals this, solve for Q. Easy. All right, so what we need is all the Q's on one side. That's going to give us 10. So we've worked out this one here. It's 10. Now all we need is these guys. So let's calculate the marginal cost at a quantity of 10. So marginal cost equals 2Q. Marginal cost equals 2 at 10. So that's going to be 20. And we want price. Price equals 60 minus 2Q. So what will that price be if the quantity is 10? All right. Now we're ready to go. what we want to find is that triangle there, and we can find it by finding this area and dividing it by 2. So what is that area? That area is 15 minus 10, 5. And 40 minus 20 is 20. So 20 times 5 divided by 2. That is the monetary value of the deadweight loss, $50. Hooray!